wondered why maths matters outside of school? Spoiler, it kind of shows up everywhere. In this video we're going to break down some key mathematical concepts clearly and simply. Whether you're studying, relearning, or just curious, you're in the right place. Please remember to like and subscribe, I really appreciate the support. Let's get into it. If I want to find the component of a vector in the direction of another vector, that is finding the vector resolute. So if I want to find the vector resolute of a equal to I plus j plus 3k in the direction of b equal to 3i minus 2k, I'm simply just finding the component of a in the direction of vector b. So I have two options for how I want to go about that. On the formula sheet, we are given this formula here. If I want to find a on b, the formula sheet gives a dot product the unit vector of b multiplied by vector b, or the unit vector of b. Now this is what is on our formula sheet. However, I prefer a slightly different formula because sometimes finding the unit vector can be slightly annoying or give me some awkward numbers to work with. So instead, the formula I like to use is a dot b, that is vector a in the direction of b, so it's a dot b, all divided by b dot b multiplied by vector b. So a dot a over b dot b is normally what I like to think of when I think of vector u, but both formulas actually give us the exact same answer. And in this example, I'm going to do it using this formula here. Okay, I'm just going to shrink this down and I'm going to place it over here. Now, if you want to use this formula, we do need to remember it, but it's a pretty easy one to remember. So to find vector u, I want to find the dot product of a dot b. Well, to find my dot product, again, I multiply my coefficients. That's going to be 1 multiplied by 3. 1 multiplied by, well, I guess if there's nothing here, it's going to be 0. And it's going to be 3 multiplied by negative 2. So 1 times 3 is going to give 3. And then 1 times 0 gives 0. So it's going to be 3 plus 0. And then 3 times negative 2 gives minus 6. All of that is going to be divided by b dot b. So the dot product of b dot b is going to be 3 times 3, which gives 9, plus 2 times 2, which is going to give 4. All of this is going to be multiplied by vector b, that is going to be 3i minus 2k, because that is going to give me my direction of my vector resolute, or my vector projection. So 3 minus 6 is going to give negative 3. 9 plus 4 is going to give 13. So minus 3 over 13 outside of 3i minus 2k. Now, I could expand it, but normally we like leaving our vectors in a simplified form. So on most exam papers, this would be a fully acceptable answer. And I've now found my component of vector A in the direction of vector B. Find the scalar resolute of a is equal to I plus j plus 3k in the direction of b equal to 3i minus 2k. Now, when I'm finding the scalar resolute, that is just the length or the magnitude of the vector resolute. So sometimes the way I want to solve these questions is if I've already found my vector resolute, I can just find the magnitude of that vector and I will get the same answer. However, if I'm just asked for the scalar resolute, then I have a formula I can also use to find my scalar resolute. That is simply the magnitude of the vector resolute. That is equal to a dot b over the magnitude of b. So let's just start by finding the dot product of my two vectors. That is going to be simply equal to my coefficient of I multiplied by my coefficient of I. That is going to be equal to 3, plus I have my coefficient of j here, multiplied by my coefficient of j. And again, I have no j component, so it's going to be 1 multiplied by 0. That just gives 0. Plus my final term, which is going to be the coefficient of my k. That's going to be 3, multiplied by my coefficient of k in part b. Well, 3 times negative 2 gives negative 6. Let's just erase this and make this a minus. That is negative 6. All divided by the magnitude of b. Well, to find the magnitude of b, that is simply equal to the square root of my I component squared plus my k component squared. Well, 3 squared gives 9, minus 2 squared gives 4. That is going to be the square root of 13. So I can replace my magnitude of b with the square root of 13. Well, 3 minus 6 gives negative 3 all over root 13. And if I want to rationalize my denominator, which I should, that gives me my simplified answer as being minus 3 root 13 over 13 for my rationalized denominator.